know, do you use the CPA approach when it comes to teaching mathematics? You might be thinking like, whoa, Marcy, I need you to back up for a second. Like, what did you just say? Today, we're going to be talking about the CPA approach when it comes to teaching math. And when I say the phrase CPA, I am not talking about like accounting or taxes or anything like that. So CPA is actually a research-based strategy that you can use when it comes to teaching concepts with your students. So you might be thinking, what does CPA mean? So if you're ready, give this video a big thumbs up. Don't forget to hit that subscribe button as well because we release new content every single week. And let's dive in and get started. So, Marcy, you just used the phrase CPA. You said that you're not talking about taxes. So what does that mean and how can I apply it to my classroom? Well, CPA stands for concrete, pictorial, abstract. This is the shift that we want our students to make. When you hear the word concrete, I want you to think of manipulatives. This is what is going to guide our students to help solve a problem. Pictorial is going to be more of a visual type of representation. And then abstract is going to be more mental math. So it's our job as teachers to get our students from thinking in a concrete way of using objects and manipulatives to help them solve a problem to the more abstract process, which is going to be more mental math. So today we're going to talk about how we can use that CPA approach and applying it to our math centers. And first I want to say that the CPA approach, it can be used with any mathematical concept. The examples that I'm going to show you today are going to be with addition with regrouping. So I am going to break down and I am going to show you some different examples of math centers that involve addition with regrouping and how you can apply those three different levels, concrete, pictorial, abstract, and how you can apply them to your math centers when students are working independently. So the first example I am going to show you is going to be the concrete approach. This is when your students are going to be using actual manipulatives. They are going to be physically moving objects to help them solve an equation. So the examples that I am going to be showing you today, I just want to kind of a preference. I'm going to be showing you these three strategies using materials that I have actually created and I have for sale in my website or my TPT shop. These same strategies that I'm going to be using with these activities, the same approaches, they can be used with any type of activity that you have. I am just using resources that I have on hand to show you how this could apply in your classroom. So first I am going to show you concrete. When I say concrete, I want you to think of physically moving manipulatives and objects to help them solve an equation. And when it comes to regrouping, how would our students use a concrete approach? Well, that is going to be using either base 10 blocks. Maybe they might even be using place value discs as well. So I am going to flip the camera around and I am going to show you how this concrete approach can be used in your math centers. So in this concrete example, we are going to be using an addition place value map along with base 10 blocks. And so how my students are generating an equation, you could use dice, you could use number cards. I'm just going to use a simple task card to show you how this strategy works. And I actually already built the problem out using base 10 blocks just to save some time. So the problem that they are going to be solving is 66 plus 48. So they are actually going to use base 10 blocks to physically build out this equation on their work map. So they're going to build out both add-ins. So in my first two boxes, I built out the numbers 66 with base 10 blocks. And then underneath in the second set of boxes, I built out the number 48 using base 10 blocks. So then down here in this space below, I am going to, again, I'm going to write out my equation that we are going to solve. So one of the things I always have my students ask themselves when solving multi-digit numbers is, okay, where do we start first? And they should know that when adding multi-digit numbers, they should start with the ones place first. So we are going to add 6 plus 8, and they might already know 6 plus 8 in their head. They might actually physically count how many ones they have. That is going to depend on the level of your student. But we know that 6 plus 8 equals 14. Now, when we are adding, and we're adding in the ones place first, if our sum equals a 10 or more, they should know that they have to regroup. And so what I like about this type of strategy and physically maneuvering base 10 blocks is that they can actually see the regrouping concept take place. So 6 plus 8 equals 14. 14 is 10 or more, so I need to regroup. And here they are going to need a strong understanding of place value and understanding that 10 ones can be exchanged for a tens block. So I like this because it has the 10 frame built into it. So I might have them actually fill up their 10 frame. So we created a 10. We have 4 left down here at the bottom. And so once they know that their 10 frame is completely filled up, they know that they can physically take these 10 ones and they can exchange it for a tens block. Now they can count the value of their base 10 blocks to solve for the sum. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 111, 112, 113, 114. You could also, if you wanted to, you could actually have them do another trade out here, and they could exchange 10 tens blocks for a hundreds block if you would like for them to do, or if you would like for them to do that. Now I'm going to show you one more concrete process for when it comes to addition with regrouping. And instead of using the base 10 strategy, we're actually going to use the open number line strategy. Now, this is one of the more complex strategies that our kids are exposed to when it comes to addition with regrouping. But what is great about putting a concrete process, so the use of manipulatives with the open number line, they're getting that visual representation that is going to make this strategy sort of click in their head. So let's take a look. We are actually going to look at this photo example here. So in this example, we were solving the problem 36 plus 38. Now, we're using the open number line strategy, but I'm also going to actually use manipulatives, and we are going to use those base 10 blocks, and we are going to use that on our open number line. So how this works, so here we have 36 plus 38, right? So I teach them to circle the larger add-in. This is going to be the number that goes first on their open number line. So I teach them to put the larger add-in at the beginning of the open number line. So then they are going to take the second add-in and they are going to build that number horizontally on their open number line here. So you can see they're actually building out the number 36. This is going to help them visually see, like when they're hopping on a number line. That's what I call them hops. I don't know what else they would be called, but this actually helps them visualize the number 36 going across the open number line. So then they would draw their hops, 10, 20, 30, and they can, by seeing the base 10 blocks laid out, they can actually see, okay, my 10's hops need to be bigger, and I call the ones, instead of calling them hops, I call them skips. So then they can see that that is going to be smaller. So they're going to line their base 10 blocks up horizontally on their number line, and then they can draw their 10's hops and skips to help solve for the sum of this problem, which would be 74. Once they have that concrete learning down, they are ready to move into a pictorial process. And concrete and pictorial, they kind of go hand in hand. And so when you hear a pictorial process, this is going to be something that your students can actually physically draw out on their paper to help them solve an equation. So the reason why pictorial representations are so important is because your students aren't always going to have access to manipulatives to help them figure out the answer to a problem. Let's say they're taking an assessment and maybe they're not allowed to use manipulatives to help them come up with their answer. But by using a pictorial representation, something that they can draw out on the paper to help them solve, is something that they are always going to have access to. So I am going to show you 3 pictorial representations using 3 different strategies for addition with regrouping. The first one is going to be base 10 that I just modeled using base 10 blocks. Then I will share the expanded form strategy and followed by the open number line strategy. So I am going to model a pictorial representation of the base 10 strategy using an activity that I have called Hunt, Find, and Add. So with this activity, your kids are going to have a picture card, and inside their picture, they are going to have to hunt for different addition with regrouping problems. These problems, they are in a smaller font and they're in a smaller size. Some are really easy out in the open for kids to spot, and then some are a little bit harder for them to find. So just to keep my kids engaged with this type of activity, I like to give them maybe a little magnifying glass or something like that to actually help them hunt and find the problems. But I'm going to show you how kids can use the base 10 strategy with this type of math center, because you might have something similar or a similar type of activity that your students are doing. Let's use the example 29 plus 45, and that's found right here. And so I'm going to write the equation up here at the top, 29 plus 45. And instead of using physical base 10 blocks to solve for the sum, I am going to draw them. To do that, I am going to draw a line to represent a tens block and a dot to represent a ones block. So first I'm going to draw out the number 29. And then directly underneath, I'm going to draw out the number 45. So when adding multi-digit numbers, they should know that they have to solve for the ones place first. When they count up their number of ones, they will see that 9 plus 5 equals 14. So what I teach them to do is that because they know that when it's more than 10, they have to trade those out. So I have them actually mark out 10 ones, and then they have to replace it with a tens block. And so then they can count their tens to solve for the sum. So they know that 29 plus 45 equals 74. The next pictorial representation that I'm going to show you is going to be using the expanded form strategy when it comes to solving regrouping problems. And the reason why I'm considering this pictorial is because they can actually solve it on paper. They are not using any sort of physical manipulative to come up with their answer. So let me show you how this would work. For this example, I chose to use a different type of math center activity, again, just so you can see how these different approaches can be used with multiple different center activities. So this is a crack the code. How this would work is each student would get a picture key. From there, they have to use the key to generate the numbers for their problem. So let's do the first one together to show you how expanded form strategy would work. So first we have a treasure chest, which represents the number 62. So they would write 62 plus the pirate hook equals 86. Now, for them to use this strategy, there's not a whole lot of space right here for them to actually solve the problem. So I like to encourage students to either use a piece of scratch paper or they can utilize the back of their recording sheet. And so that's what we are going to do. So let's see, our example is 62 plus 86. And this time I'm actually going to write it vertically. So when it comes to the expanded form strategy, they are going to solve using expanded form and place value. So 62 is going to become 60 plus 2. Then 86 is going to become 80 plus 6. From there, they are actually going to make this an addition problem. They're going to draw another plus sign and an addition bar. And I actually have them circle this plus sign right here because this same strategy can be used for subtraction. And so I have them circle it so they know what they are doing. So then they're going to solve vertically, starting with the ones. 2 plus 6 equals 8. 0 plus 0 equals 0. 6 plus 8 equals 14. What this does is this actually takes the regrouping part of the problem, it takes that away. So now they have 140 plus 8 equals 148. And so this would be a pictorial type process because they can actually draw this strategy out on paper. And now I'm going to show you one more pictorial representation with addition with regrouping, and this time we're going to use the open number line strategy. Using the open number line strategy can be a bit more challenging, but from my experience, after exposing my students how they can use an open number line to solve multi-digit problems, you would be surprised how many actually choose this type of strategy in order to solve their equation. Now, when they're first starting out, I actually like to have them write out the process of how they would solve this. So here in this example, we have 59 plus 35. So the first question I'm going to ask them, okay, what number is going to go at the beginning of your number line? And so I like to teach my students to put the bigger number or the bigger add-in at the beginning because that's less hops they have to make on their number line. So we're going to start out with the number 59 and we're going to write that here. And then we are going to put 59 at the beginning of our number line. Then the second question I have them ask themselves is, how many tens do you need to count? So we're adding on 35. So we need to hop 3 tens. And then how many ones skips do you need to count? So what number is in the ones place is a 5. And the reason why I call the tens hops and the ones skips is because a hop is a little bit bigger than a skip. So when they're drawing on their number line, I have like their hops, I'm going to do it up here, their hops are going to be bigger than a ones skip, which is going to be smaller. So now they are ready to solve for the sum. So we started out with 59. They need 3 tens hops. 1, 2, 3. And they need 5 ones skips. 1, 2, 3, 4, 5. Now they can count and solve for the sum. Sometimes, like, you might have your students have, like, write out plus 10, plus 10, plus 10, 1, 1, 1, 1, 1. Some kids will eventually get to the point where they don't need to write these numbers up here anymore. So it's going to be 59, 69, 79, 89, 90, 91, 92, 93, 94. So 59 plus 35 equals 94. And again, this is a pictorial representation because they can physically draw this out on paper. Once your students have mastered the concrete process, they have pictorial down, they are now ready for abstract. This is our whole goal, is to get them from concrete learning to abstract learning. And with abstract learning, I want you to think mental math. This is when they can solve an equation or they can solve a concept. They can complete it without the use of manipulatives. They can do it without the use of visual representations. This is when they can use mental math to help them solve the equation. So I am going to show you a few more examples of how you can use an abstract representation in your math centers using addition with regrouping. In this example, we are just going to use a traditional flip and add activity. For this, all your students are going to need is a set of number cards. That's it. That's all they need. They can solve for the sum in a math journal. They can write on a whiteboard, a piece of scratch paper, whatever you want them to use. And so how this works is they are just going to flip the number cards to create an addition problem. So my first addend is 54 plus 29. When you think of abstract learning when it comes to addition with regrouping, this is when I want you to think about the standard algorithm. This is going to be the more traditional method for solving regrouping problems that we learned when we were in elementary school. So how the standard algorithm would work, we have 54 plus 29. 4 plus 9 equals 13. We know that with 4 plus 9, when that equals 13, when it's 10 or more, we have to carry next door. Their 3 is going to stay in the ones place. The 1 is going to carry over to the tens place. So then we have 1 plus 5 plus 2 equals 8. So 54 plus 29 equals 83. And this is more of an abstract learning process when it comes to addition with regrouping. So there you have it. There are several different examples of using a CPA approach, concrete, pictorial, abstract, when it comes to addition with regrouping and students working independently in math centers. Remember, one of the big goals of math centers when you are running a guided math style structure in your classroom, they are working independently. And you want them to be able to work independently on their own level. And so what is great about almost all of the activities that I just showed you, each activity was different, right? But I used a different approach and a different strategy with each activity. When it comes to math centers, use the CPA approach to help you differentiate student learning. If you are looking for addition with regrouping resources, I have several recommendations I'm going to drop in the description of this video. I have an addition and subtraction with regrouping guided math unit that includes lesson plans, and then those work mats, those place value work mats, and that number line work mat that you saw in this video can be found there. And then I have an additional separate set of addition with regrouping math centers, and those were a part of the examples that I just showed you. So the hunt and find and the crack the code and so much more. I'm going to drop the link for those as well. The best part about those is they include student instructional videos, so you don't have to waste time explaining to your students what they should do. There's a video of me showing them already. So if you have any questions about the CPA approach and how you can incorporate it more into your math centers, I would love to know. Leave me a comment below, and I will see you guys in the next video. Bye.